Hi everybody, I am Hiba Izzat, and in this video I am going to show you how can we describe our data in a graphical way. So in previous videos I have defined what is data and what are different types of data. Of course I have gone through the how can we collect data. So after the process of data collection, we need to understand or to describe our data. At the first step, we can describe this data graphically. Then we can describe it using some numerical measurements. In later video, I will explain how can we describe the data numerically. In this video, I am going to show you how can we describe our data graphically, so we can understand or we get information from the data visualization. To describe the data in a graphical way or to describe it using visualization, we need at the first step to define what is the type of the data set. In previous video I have told you that the data set can be classified into one of three types. It's either a univariate. In a univariate data set we have only one variable, or it's a bivariate data set, so in this case we have two variables. And the third type is multivariate, and of course it's much harder to be described graphically. The data in front of us represents a survey collected from students in order to know how many students are following the different ways of purchasing their books. So 147 students said that they bought their books from the campus bookstore. 66 students informed that they bought their books from the retail outlet, and 49 students bought their books from websites like Amazon, and only 7 students bought their books from other students, maybe they are used or second-hand books. So in this case we have the count. It's a univariate data set. For each student we have here the data set contains one column for the variable, okay, and we have here 4 observations, the methods of buying or purchasing the student textbook. Of course, to represent this data in a pictorial or to provide pictorial description, clarification of the data, the number of students seem to be a little bit not informative, because it would give you the total count, but in this case maybe we are more interested to know the percentage of each student following different way in purchasing the textbook. So we can or we will represent this variable in terms of a percentage. So to do this we are going to type an equation that calculates the ratio of each method divided by the total number of students. The problem here is that if we write the equation this way and we we are going to drag this cell, we will get an error. This error means that there is a division by 0. Why is that? Because when you are dragging the cell, not only the number at the numerator is changed, but also the number of the denominator. So here we have in C9 it's empty. In this case it will be treated by Excel as it's a 0. So to avoid this problem, we will fix that all these cells should be divided by the total, not the preceding cells. So in this case, I am going to fix this by adding the $sign shift 4 from the keyboard, so in front of 8. So in this case it always will be divided by C8. So here we'll find the problem is solved, because if we go to any cell, we'll find the increasement in the number of cells. Here it's C4 divided by C8, here it's C5 divided by C8, and so on. So for the univariate variable, we have some number of chart types that are very suitable for this kind of data set. The most famous example is the pie chart. So to graph this, I'm going to select, of course don't insert the total inside your graph, because this will give you pies visualization. So I'm going to select the 4 methods, and while I am pressing the control button in the keyboard, I'm going to select the percentage. This is how I can select 2 different places. Then I'm going to the menu insert, and I will choose the pie chart type. There are 2 types. It can be represented by a 2D or 3D. It's totally upon the purpose of your presentation. So I can select this type. If I want to add the numbers that is representing each one, I can right click over the chart itself, not in any area, the pie chart. Okay, then I'm going to add labels, data labels. So here the number or the percentage of each method is very clear on the chart. Of course, as we can read this chart, it's about 50% of students purchase their textbook from the campus bookstore. So here, why is the percentage is very informative than using the ordinal count alone. So if we wanted to add or to make our chart looks prettier than this, I can change, of course, the chart title, okay, to represent what is meant here. So I'm going to take this title as copy, and I go here and paste it. Okay, and I can also change this using different color, for example, and do the usual text format you want here. And of course for the labels you can do the same. Okay, here if you want to change the appearance of your graph, you can go to chart design and you would find different designs. Of course it differs according to the choice of each one. Of course this appearance looks very good, but if it's intended for only online visualization or something like this, because it's not a printer friendly design. So you choose which one that is most suitable for your presentation. It's totally upon your choice. Of course, after selecting and changing everything, you can change the type of the graph without going back and do so much changes. You just click over the chart area and you select change chart type. So we have selected the 2D pie chart. We can select the 3D pie chart. So as you can see, we can change the appearance of our graph and the chart type without doing so much changes in our chart. Okay, so this is the first type of data representation in Excel. Of course they are very beneficial for reports and output, and you can take of course any graph, copy, and you can insert it inside any Microsoft like Word or PowerPoint or something like this. Okay, so this is the first type of charts. Okay, for also the univariate type, we have two other types of graphs, which are the column and the bar chart. For the column and the bar chart also again we have some observations, and we want to represent their percentage in the total of the data. So here, to add a column chart, we just select our data and go to insert and choose the bar or the column chart like this. We have also here in chart design we have different types of presentation. They may differ according to the color or the final output. You are totally free to choose which one fits the purpose of your presentation the most. Okay, so here again I'm going to change the title of the chart. Okay, I can add here the title for the x-axis and for the y-axis. I would simply go to chart design and here add chart elements. For the axis titles, I am going to insert the primary horizontal. Horizontal refers to the x-axis, and here I'm going to write company. Okay, as this axis represents the company, and I'm going also to add axis title, the vertical axis title. In this case it refers to percentage. Okay, if you wanted to change the font type of the whole graph, you can simply select the whole graph, go to home and change the type of the font as you want. It will be changing for the whole graph, as you see, with different sizes, of course, according to the size you already put. Also, I can change the color of the whole graph. Okay, and to change some items specifically, I have to select these items. So to stress some of the titles, for example, and so on. So here it's the graph that is representing our univariate data. We call it the columns, as it represents the percentage of each company in as a column, the percentage of as a column. Of course, this visual representation of our data set is very useful, as by just looking, even if these labels are not inserted in the graph, you can from the first look conclude that Goodyear company has the maximum percentage and the Dunlop company has the minimum percentage inside all the companies shares their market share in the industry of light vehicle tires. So in order to change again this we can either build a new chart like this and go to insert charts, and this time we can use the bar chart. Okay, so here the companies, instead of being represented in a at the horizontal axis, the companies are represented at the vertical axis. So the same, almost the same purpose, the difference between the two types of presentation is the final visualization. Which one would you prefer to represent your data? And again we can change this and add the chart title and so on as we did. Can copy this and paste here in the chart title and so on. We can change the font size. We can also add chart titles. In this case the horizontal is not the company, it's percentage, and for the vertical axis we have company name. Okay, of course, because this data set is also a univariate. In this case we can also represent it with the pie chart as we did in the previous data set. So this can also be represented as a pie chart. Okay, so if we want to represent only percentage or the contribution of different observations, the different individuals inside our data, we can use one of these three types of charts. Either we can use the column chart or the bar chart or the pie chart. If we have a data like this, as we have different observations at each year, we have here different the same time lag. We have these numbers for each year from 1980 to 2015. In this case this data set is or represents a time series data. For the time series we said we may have some observation or some value for a variable over years, over time, and of course the time lag, the time distance should be the same. We have here in the number of experts, the value of experts in billions of dollars for each year. So again, it's not considered as pie variate because we are representing for each year experts, okay, and imports. Here the relationship for the imports and exports is for years. So here, to illustrate, I'm going to select the whole data set, and we are interested in this type of visualization is to compare or to put the two variables in the same graph. So here we are interested to see, to investigate the evolution of experts over time and the evolution of imports also over time. So we are going simply to select the data set, go again to insert, and in this case we are going to select X and Y scatter diagram. We can represent our data with different types. It's more preferred to have a line. You can use this one with curvy or this with sharp ends. It's totally yours, as long as both of them are fitting the purpose of presentation. So here in this graph, as you can see, why I'm telling you it's only it's not considered as a bivariate, because we can delete the line of imports by, we can click on this line and we can click delete. Okay, the import doesn't affect it. Why is that? Because it shows us the evolution of imports with respect to the year. So we have here the scatter, or the relationship between years, time, and one of the variables. And of course it's a time series data set. Why? Again, because we are interested in the evolution of the import value or variable with or over time. If we'd like to add the second line, the experts line, in order for more clarification or for comparison reason, we can right click over the chart area, and we will select data. We choose select data. Okay, here it seems only that we have one time series for the imports. We want to add the new time series. In series name, would choose experts. For the x values, we can choose the same as imports, and here for the y value we can choose these values and then click OK. As you can see, we have here now two time series, one for the experts and the other for the imports. Okay, again, to add the chart title, we can go to add chart element, and for the axis title, we have for the primary one, we can add year. Okay, and for go to chart design, for the primary vertical we can have US experts and imports. Okay, and to add the title for the whole chart, we can choose the title. We can take this, copy and put here, paste. Okay, so now we have our chart ready for the presentation. So this is the fourth type if we want to add a scatter or line presentation of our data. And of course this data set is a time series data. The most important type of graphing is to represent the frequency of our data. And here by frequency we are interested to know how many of the observations are valued with the 59 or within the ratio between uh, 60 and 50, for example. So here we have many values that represents the price and price to earning ratio for 44 randomly chosen S&P 50 stocks, S&P Standards and Poor 500 stocks represent the main index of the US stock exchange market. So here we have many values. If we want to know in the range, if I'm going to define this data, okay, so if I take this data, copy and put it here, paste, okay. If I want to know what is the minimal and the maximum number within this data, I can go to sort and filter and sort from smallest to largest. So here we have the smallest value is 7 and we have the maximum one is 59. So in frequency distribution, for example, I want to know if I'm going to put a range of between the range of numbers between 5 to 10. If I'm going to put I'm trying to format the cell because it appears like date or something like this. Okay, so here if it's from 5 to 10, okay, and from 10 to 15, okay, then from 15 to 20. So here we have different periods, different ranges of data. So if we are counting the data, we want to know the frequency of the values that are included from 5 to 10. We have here 1, 2, 3, 4, 5, 6. So we have here 6 of our data included in the period or in the range from 5 to 10. For the second range from 10 to 15, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have here 10, and so on. We are going to do the same for the rest of the observations. This is called the frequency distribution. I want to know how many of our observations are included within the first class from 5 to 10, and how many of our observations that are included in the second class from 10 to 15 and so on. We repeat this for the whole data set. Okay, so this is called the frequency distribution. So how can we represent this frequency distribution in a simple graph or a simple chart? We can select our data and go to insert. Inside the chart we have, this is different from this we used it, it's the column or bar chart, but here it's the histogram. It's called a histogram. So we are going to select the histogram. Histogram usually and always used to represent the frequency distribution of our data. So for our here the frequency distribution or the histogram, as we can see, it automatically divided our data into different classes. Okay, the first class is between 7 and 18, and usually these classes should have the same size as we did from 5 to 10, from 10 to 15. So we have here the difference between each class is 5. Here it's from 7 to 18, and here from 18 to 29, and from 29 to 40. So here the distance is usually 11. Okay, in the first class, which is from 7 to 18, we have about 25 or less of the observations. Again, to change any criteria or to change the chart title, we can take this title, copy it and paste. Here for the horizontal axis we have here classes, and for the vertical axis title we have frequency, and of course again if we want to change this look into more looks that we think it's better or something like this, we can usually change from the chart design. It shows us different ways to represent our histogram. So here histogram is very important to know the distribution of the data. This, for example, shows us that most of our data are included in the first class, which is between 7 and 18, and then about half of our observations are included in the class of 18 and 29, and there are the frequency were 13. In later videos, we are going to describe the distribution, if it's normal distribution or skewed to left or right, based on this histogram. So histograms are very important to show us the distribution of the whole data set. Thank you for watching the video.